Good morning. Before continuing on sustainability, we missed the noise pollution. Even though in the introduction of environmental engineering, we told noise will pollute the atmosphere. So we just tell something, a few points on noise control and pollution due to noise. Noise is defined as any unwanted sound. Any unwanted sound is a noise. For a noise to take place, it is not necessary that noise generation is loud. Or in other words, the loudness of the noise is not always the reason for creating a noise. For example, just to think that you are going to take your bed at night. A rain starts outside, exterior. Once the rain is over, there will be some droplets falling down. The noise of the falling droplets will be more once they fall on a metallic surface, such as a tin sheet. Just assume that it is a tin sheet. The loudness will not be there, but this dripping water drops falling from a height of around 8 feet or 9 feet or even 10 feet, falling on the tin sheet, create an irritation, a disturbance for sleeping. Loudness is not that much, even then that is called a noise. A dripping water on the tin sheet. Similarly, a leaking tap. Suppose in a bathroom, you close the tap, but because of the fault of the washer, suppose a small drop falls, and usually you store it on a mug or a bucket. Whenever this drop falls on the bucket or the mug, if you are in the nearby area, when the ambient, the atmospheric sound is less or the noise is less, the droplet from the tap falling on the bucket or the mug will cause an irritation for the ears, and that irritation is called noise. Or that irritation is due to noise. Usually noise will be loud or louder unwanted sound or disturbance are called noise. But it is not necessary that noise need to be loud always. Noise generating equipments are there. So many heavy equipments such as generator itself, compressor, pumps, washing machine, vacuum cleaner, grinder, mixie, refrigerator, air conditioner, road movers, construction equipments, road rollers, tractors, jet aeroplanes, landing and taking off. When the jet airplane takes off, hectic noise will be generated. Then noise from the traffic noise. So sources of noise are many. Then amplifiers generate noise. Then how this is quantified? Noise is quantified. Noise is expressed in decibel, 1/10 of a bell. It's a logarithmic scale. It's a ratio, a relative quantity, ratio of two sound pressure levels, or power level, or intensity level. Decibel. Starting from 0, 10, 20, 30, 40, 50, 60, 70, 80, 80 and 90. This is the 80 to 90 decibel is the sound pressure level, comfortable sound level for an exposure period or duration of 8 hours. So usually in industries, the workers who are having a shift, usually they will have an 8-hour shift. So they shall not be exposed to a sound pressure level or noise level of more than 90 decibel when the duration is more than 8 hours. So the maximum sound pressure level which they can be subjected to is 90 decibel for an exposure duration of 8 hours. Like that, you have legislation and rules for all noise generating sources, equipments, firms, factories, everywhere. Usually, traffic noises are suppressed using mufflers and silencers. Usually, the role of the silencer, the word itself, the silencers suppress the noise. Otherwise, the noise generated from from the vehicle, especially the two-wheelers, will be more. And if the silencer is faulty, or if there's a small hole somewhere in the body of the silencer, again that noise will be very irritating to the ears, uncomfortable. It will cause discomfort. Maintenance of vehicles and upkeeping of the silencers are very important, because if they are not properly maintained and kept in good condition, noise will be unnecessarily generated. Noise generation is from three elements of sound generation process. Three elements or three components of sound generation process. One is called the source. Source. The mic, for example. Suppose a person talks in front of a mic, that is the source. Microphone. Amplifiers. There are sources. Then the path. The sound has to travel from the source to the destination. So the medium is called the path. So source, path, then the destination. Destination is called the receiver. Destination is called the receiver. The earphone, for example, it's a receiver. Then the audience for an orchestra or for a speech or for a drama, they are the receivers. The performers and the stage from where you have the noise source generator. The auditorium media acts as the path. So source, path, and receiver. You have closed air theatres and open air theatres. Both are there. So source, path, receiver, SPR. Whenever there is lack of control or poor maintenance or poor performance, either in the source or in the quality of the medium path or in the receiving part, noise will be unnecessarily generated. So you have three ways by which you can control the noise or suppress the noise. Noise control suppression is called noise abatement. Noise control or noise abatement. You can abate the noise either at the source or at the medium or the path or at the receiver. Usually you confine the source. Noise generating sources will be confined. They will be isolated. Only the required noise level or sound pressure level will be let out. So by confining the source, and you will be using mufflers there, just like silencing. Here you will be using mufflers, thick blankets on the separator cabin or the confinement or the enclosure, by which the unnecessary noise will be masked or absorbed by the mufflers, by which only the required sound level will be spread out. The process of sound transmission, noise transmission from the source to the receiver are twofold. In two ways, noise will be transmitted from the source to the receiver. One is called the structure-borne noise, B-O-R-N-E. Structure-borne noise. For example, this is a structure-borne noise. I hit on a table and the table generates the noise. Through the table, you get the noise. Then that noise generated because of the vibration of the structure or structural element, it is called structure-borne noise. I talk and the people hear. Then the noise is generated by the medium, as air. So airborne noise. Usual noises are generated through air. So airborne noise, a general category and a special category is the structure-borne noise. When machine foundations, for example, if you have vibrating equipment, noise and vibration go together. Vibration also creates noise. So if a heavy equipment vibrates or works on a platform, then you hear the noise even though it is through air. First it is transferred because of the foundation or the bed on which the equipment is stationed. So there is a structural borne noise produced which is transmitted through air as an airborne noise. So structure-borne noise, airborne noise, or a hybrid noise, a combined structure-borne, then subsequent airborne. So if a machine is vibrating on a platform, we may have to use resilient materials such as rubber, plastics, even wood. Wood is a good resilient material. So some cushioning material known as the shock absorbers. Just like the purpose of the shock absorber is to control vibration. That is why they are called shock absorbers. So if you give shock absorbers by resilient cushioning materials such as rubber, plastics, wood, or boards, you can, to a great extent, suppress the structure-borne noise. So many musical instruments fall under the category of producing structure-borne noise or airborne noise. Flute, for example, produces airborne noise, wind type. Percussion equipments. So they create structure-borne noise. You can categorize, you can as an exercise, an academic exercise, you can categorize the musical instruments either in wind or air type or structure-borne noise. See, since the sound is modulated, receiver is not getting a noise but a very pleasant sound distribution. That is called the acoustics. Just when the noise is suppressed and pleasant sound distribution is experienced or realized, then that part is called the acoustics. So acoustics is good sound distribution, noise is bad sound distribution. So everybody likes acoustics, but nobody prefers noise. Actually, in that case, you are suppressing the noise, but the music may be louder. That is another aspect. The music may be louder. They'll be singing with high pitch, but it is pleasant and pleasing to the ears. They no longer act as a noise. That is the beauty of perfect sound distribution, for which civil engineers have to plan the land, plan the buildings, plan the source, medium, and the receiver. And usually noise and vibration control, the techniques and the equipments and the design are the role of mechanical engineers. Only the land and building and using the proper materials, that is vested in the hands of a civil engineer. But the noise and vibration control technique is usually handled by mechanical engineers. So noise control can be either at the source or at the path or at the receiver. So in the path also, if it is making structure-borne noise, the structure which is vibrating untowardly has to be arrested. The vibration has to be controlled, vibration of the structure has to be controlled with resilient materials by which in the path spreading of noise will not be there. Then the orientation of the amplifiers, speakers. Orientation of the speakers should be such a way that distribution is even, distribution is without any defects, any acoustical defects. It is uniform, even distribution everywhere, irrespective of the location of the listener. Whether the listener sits in the front row or whether the listener is sitting in the last row, he should be, both of them should be hearing the same decibel. There should not be excessive noise at the front or reduction in noise at the back. So the speakers, orientation of the speakers, the number of speakers, alignment of the speakers are to be managed to tackle the noise generated and spread through the medium of the path. How will you control the noise at the receiver? Usually in industries, the workers will be given earplugs. They will be having earplugs. And those earplugs will enable them to be safe and to be away from hectic noises. Earplug is one of the methods by which you can restrict noise at the receiving end. And each worker will be monitored for their noise exposure level. And the equipment used for noise exposure level is called noise dose meter. Noise dose meters, just like our calculator or mobile phone, a small gadget will be there. They have to keep it there in pocket, and it will be ready reckoned, monitored very often. A noise auditing, just like an energy auditing, a noise auditing, and it will show the peak values of noises by which the worker is exposed to. According to values, according to the statistics of this noise levels, the worker will be protected either by using the earplug or reducing his exposure time or doing something on the path or the source, confining the source more. The effectiveness of confinement of the source will be a factor of the values of the noise dose meter. The noise levels are expressed, I told you, in terms of decibel, and you have precision sound level meters, sound pressure level measuring meters, sound level meter. Sound level meter will give you noise level. You have diaphragms simulating the diaphragm of ears. So they will sense, and you have analog sound level meters and digital sound level meters. Nowadays, you have digital sound level meter which can be connected to the computer, and you can get the variations and any statistics, any interpretations are possible. We have diaphragm of varying sizes. Whenever the size of the diaphragm is lesser and lesser, its sensitivity will be more. There are different scales, weighted scales according to the type of the source. Decibel A, decibel B, decibel C, like that. Average noise level values according to the frequency of the sound. According to the frequency. Some sounds have only single frequency. They are called a pure tone. Some sounds will be generating with varying frequencies, altering frequencies or alternative frequencies. So accordingly, you will have different weight scales on the sound pressure level. This sound pressure level is an object. If it is going very much near to the sound field, there is a possibility of the sound field getting disturbed. So if you want to measure the sound pressure level, not taking the sound meter very near to the source, you can keep the meter at a higher, at a distant point, and you can use a probe microphone. Instead of the microphone having half an inch, 1 inch, 3/4 inch or quarter inch, you can have a probe needle-like microphone which will be very sensitive, that can go near the source, and the sound level meter will be, precision sound level meter will be at a distance. So sound will be measured, and according to the sound pressure level, noise will be controlled at the source or at the path or at the receiver, by which the structure bound noise as well as the airborne noise will be taken care of, and the vibration will be controlled using shock absorbers, cushions. Mufflers will be used for reducing noises at the source. Silencers will be used in the case of vehicles to suppress the noise. This is a small overall view of noise control pollution. Thank you very much. God bless.